example 3, we are given two limits. The limit of f as t goes to 3 equals 5, and the limit of g as t goes to 3 equals negative 2. Using this information, determine the following limits. So we know that the limit of f and g, they exist, independent of one another. That was what we're told. So that tells us we're free to use all the limit laws, unless additional assumptions apply for some of them, which for some of them they do. So for part A, we've got the product. Well, we know that if the limits exist, then the limit of a product is the product of the limits. So we can go ahead and just do 5 times negative 2, which is negative 10. For part B, we know that the limit of g exists, and we know that the limit of 1 exists. In fact, there's a law, if we go back to the previous page, number 7 says that if you have the limit of a function raised to a power, you can just take the limit of the function and raise that answer to the power. That's exactly what we have right here. So we can write this as 1 plus, if I take a time to write out the additional step, the limit as t goes to, is it 3? Yes, of g of t, quantity squared, which is 1 plus negative 2 squared, which is 1 plus 4, which is 5. And remember, the limit of a constant is the constant, so the limit of 1 is 1. So you got to be careful for this one, because although we have a quotient and there is a quotient limit law, that one law does have the additional hypothesis, which is that the limit of the denominator is non-zero. Since the limit of the term g is negative 2, when we add it to this 2 here, we get 0. So that's going to be an issue for us, unfortunately. So I'm going to say dne, since the limit as t goes to 3 of 2 plus g of t equals 0. Lastly, for part D, we have another quotient, but in this time, the denominator is just 2t. 2t is a polynomial, and we know that since polynomials are continuous, the limit of a continuous function is just the value of the function. So if we plug in 3 for t, we'll get 6. And then the limit of f, the numerator, is 5, so we'll have 5/6.